Hello, everyone. Thanks for coming today. So I'm going to start my talk really fast. I'm sorry, I have a class at 2 p.m. So I'm going to need to leave. So I'm going to skip some of the slides. So I'm going to talk about workload modeling for security and privacy in databases. Why this matters is that it impacts a lot of important other types of applications. I'm going to talk about an insider threat problem that we are having. So in a standard office environment, we have a lot of strong defense mechanisms. We have firewalls, password protection, anti-malware, VPN encryption, and all of these other systems that we can count on. And all of these things that we see here, all of these defenses, defend our parameters. However, when we have an insider, an attacker inside our premises, inside our office, we do not have that much protection. So these kinds of things, however, these threats come from intentional behavior. So somebody may say, if they don't pay me well, I'm just going to take it myself. These are just small transactions, nobody will notice. And it happens a lot. But sometimes they're unintentional. Maybe the person has just started working at the company, at the organization. Maybe the UI is very, user interface is very difficult to track in your company, and people may make mistakes. If there is not enough training for these types of applications, for example, your employees also become insider threats, even though they do not want to harm your organization. So one of the biggest places, one of the most important places that you keep your information, you keep your data is your database. Your information systems have a file system, and they also have database systems that are kept on file systems. So when somebody wants to attack a database, if they know how to access the database, they can do so, especially if your information systems do not track the behavior, do not really handle how people use the database. You are going to have problems, maybe not now, but maybe later. Let's talk about how this may work out, but let me switch back to workload modeling again to talk about how those access parameters, how people access the databases may matter. So in traditional workload modeling, we have a question: what kind of queries do we receive? Because what kind of queries matter in terms of how we are going to use the database, utilize the database. For example, you can have read-only query access, or you can have queries that write-only, but mostly in information systems, you deal with either read-heavy or write-heavy query workloads. In these cases, you are going to be looking at a very broad information, in a sense that you are just counting on the type of queries, if they write or if they read to your databases. And usually that is enough for modeling the behavior for many database systems. But what should we focus on to increase the performance? Usually this is the question to ask in traditional database workload modeling, because people use the workloads usually to improve the performance of the database. You can use joins, indexes, primary keys, and foreign keys. You can have your database structure optimized, and eventually, what you do is you measure the performance using two main metrics. The first one is latency, which is the time to perform one single action. And the second one is the throughput. It is the number of such actions executed or results produced per unit of time. In databases, we usually look at transactions per second or queries per second. So we have very representative benchmarks for server-side database systems. For example, when you think about TP-CH queries, there are a number of queries that measures the different aspects, different architectural parts of the database system, and you measure the throughput in many cases. So I'm going to stop here and ask a question. Which one do you think is more important in databases, latency or throughput? I have a both. Some people say it's latency. Okay, for e-commerce, for almost all types of server-side database workloads. Okay, so we have a variety of answers here. Thank you very much for everyone who responded. So when you take a look at the database systems, the DB experts usually will tell you throughput is more important because what they look at is that you have hundreds of users using the database systems. They are sending queries at the same time and the volume is large. So instead of people's observation of how they see and use the database, what is more important to you is for you to be able to handle those queries. So 100 queries arrive. If you can answer 100 queries right now, 100 queries in the next second, 100 queries in the next second, you will probably be able to deal with the workload. Even though latency is another metric, latency is maybe more important once you are able to handle the throughput aspect of the performance. But there are improvement points here. So no latency or throughput metrics will give any attention to the activity that is being performed. So you can be selecting on a table with 10 rows or a million rows, or you can be doing one access attempt to a row or 1,000 access attempts to a row, and there is no attention to what the user intends to do. So there will be different units in your organization that will say, bring me a customer who is a frequent customer, that will need to go through all the sets, all the database rows in your database on the customer table. Or another unit will ask, bring me a customer who last shopped last week, I want to send them a coupon. That's going to require you to take a look at just the rows, and if the date matches, you are fine. When you are looking at a frequent customer, you are aggregating information that is going to be more complicated. So there is a different aspect though. We have a project called Pocket Data Project. So Pocket Data are databases on smartphones. Instead of a server-side application, you have a database on the phone that is a single client. You don't want your phone to be used by anyone else. So in that case, the database that you hold on this phone is going to be used by only you and nobody else, right? So that means you have latency. Latency is more important, and throughput almost never matters. However, in these databases, the workloads are bursty, and representative benchmarks matter in this case because all of the benchmarks we see focus on the throughput because they are used to measuring the server side workloads. So let's take a look at a little bit of a closer look. There are properties for you to implement in a database, in an ideal database system: atomicity, consistency, isolation, durability. But since you are the only user on a database, if you eliminate isolation from your principles, the moment you do that, the total runtime of a workload will reduce about 50%. That is a very big difference. So can we design databases with weaker semantics? And when you do that, for example, you can improve the performance of your databases, mobile databases, significantly. When we look at throughputs of certain devices, for example, let's say this is a phone. The phones, it's a Nexus 5 device that we ran our experiments on. And let's say you can do 36,000 transactions per minute. This is what runs on a Nexus 5, which is a phone from 2015, 2014. When you have a server in your lab that's going to run, a database server that's going to run an approximate level of 112,000 transactions per minute. So when you compare these two, I'm going to say 3 of these phones are worth about this server. Am I correct in saying that? What do you think? I'm going to say no, because the biggest problem that you have here is that these phones, when you run that many transactions per minute, in a couple of minutes, they are going to burn. Whereas your servers are able to handle those problems because the cooling mechanism is better and they are designed to last. However, the phones are designed to run queries when you need them and then stop and not run the queries when you don't need them. When you look at a Facebook query workload on one of these devices, you will see this. So in a second, in one single action, Facebook can run about 1,000 queries. For example, when you do a profile click, it runs about 1,000 queries per second for a couple of seconds, and then it stops, radio silence. When you click on photos on someone's profile, it will run about 300 queries per second for a couple of seconds, and then it will stop. And then when you scroll on the feed, you can see those swipes, right? 1 swipe, 2 swipe, 3 swipe, 5 swipe. When you do these, again, 400, 600 queries per second, and it stops. So this is what we mean by bursty workloads. So if this is the case, what is going to happen is that if you can handle these bursts, you are going to be just fine. Can you design a defense mechanism around this behavioral metric? I'm going to say yes, because when we did our experiments, we had 11 lab members in our lab. We had 56 phones deployed in the wild at the University of Buffalo. And what we do here is that we can extract the behavioral patterns to distinguish them from other people. So we can take a look at sessions, we can cluster these activities, and we will end up with a certain level of confidence that we can distinguish people from each other. And also when we look at different database threads that is running on SQLite and Berkeley DB, you see that the latency increases with SQLite when you have multiple database threads. With Berkeley DB, that is also common, in mobile devices, you are going to see less increase in the average latency of a query. But the scaling doesn't matter on the phone because they are single-threaded as well. So when we think about all of those, we can actually apply all of these conclusions to insider threads. So people know you and you trust them for when you consider insiders, and they are among your ranks. So if you place a query monitoring system in your mechanism, you will see that you can take a look at the queries and create a behavioral model for each one of your users, even though it is an autonomous system, even though it's an application user. It doesn't matter if the queries are complicated, which will reflect one single time written queries for terminal users. It won't matter if it is an application user that will generate queries through an application. And it won't matter if it's an autonomous system, because you are still able to generalize and create behavioral metrics for all of these users. So when you are able to classify these behaviors, you are going to be able to detect the anomalous activities. So how can you make the anomaly detection better? You can regularize the queries. You can, for example, compare these activities over their patterns, and you can detect which users are more close to each other and which users are more distinctive than each other. And when you observe for some time, you are going to be able to detect these anomalous activity changes or benign activity changes over time. Even though the habits change, you can adjust your learning mechanism based on the same principle. Using these principles, we have collected database query activity from four different applications. As you can see, for our complete data set, we have collected 45 million queries. And using these queries, for example, for each one of these applications you see here, we set ideal thresholds, and the success rates for these thresholds when we are detecting the anomalies are higher. In all cases, we have achieved more than 86.2% success rate to catch the activities. But also when we consider the changing behavior by tracking people for a certain amount of time, we were able to improve on top of these ideal thresholds as well. And now these tracking for a certain amount of time will actually work in our favor, because now we don't need to even consider what the threshold should be, because thresholds are always risky. In real-world attacks that we injected to the query system, query workload, we again achieved over 80% of success, which is again very successful compared to existing mechanisms that look at workloads for privacy and security. So I work in the security of databases and cloud systems, and I also have projects on secure software development. That's all from me. It is 1:55. I have 5 minutes before I need to go to class. Sorry about rushing towards all of the slides. Thank you very much.
Thank you, Dr. Cole, for that. I guess do you want to take quick questions maybe, or
yes, sure.
If you have any questions for Dr. Cole, you can just drop them in the chat now.
The question is, where can we learn more about the PocketDB? I am going to say Pocket Data Project has its own website, and also I have some publications on Pocket Data workloads. Please drop me an email and I will share it with you. I will write my email address here. And I'm going to note down your name so that I can send you the links. There is a question here. Did we create an app for this? How did we collect the data? So the lab that has collected this data was Phone Lab at University of Buffalo. Phone Lab is still active, and what we did was initially Phone Lab distributed phones to the lab members and then the research community and student community across the campus. How the data was collected was that a couple of research PhD students was able to modify Android operating system, and they caught all the queries at the data access layer of SQLite. That's how they were able to collect the data. Where I come in here is the processing part. So I can, if you email me as well, I can share all the related publications and open links to the query workloads that have been collected by the research team and us. Thank you.